Hello everyone. So we'll continue from where we left off. So we were solving this problem, uh, this uh, problem where we have to find out the probability current, which is defined as the time derivative of the probability PR. In the last videos, we managed to show what PR looks like as a function of time. We'll have to start with this with finding this quantity j at time t is equal to 0. Right. Before we do that, I'll start this video with a correction. So in one of the earlier videos regarding this problem, I mentioned that for a particular C1, we'll have two values of C2, one corresponding to the plus sign, another corresponding to the minus sign. Hence, we'd have two different energies, right? Now, this information is incorrect because we'll have two different values of C2s. That's fine, and because of that, we'd have two different values of the energies. But what's not true is that those two different values of C2 correspond to the same C1 value. That's inaccurate, because if we go back, if I have to jog your memory, C2's written in terms of C1, C1 C minus epsilon plus minus beta divided by 2 pi. Now we had another condition, that is C1 mod square, C2 mod square. They have to be added to 1. So if you do that, then you'll find that C1 has two different values, right? So C1 would have I5 root over 1 plus minus epsilon plus minus beta divided by 2 delta, this thing squared. So what you have here is you have two different values of C1, and when C1 when you take the plus sign here, you would have C1 plus, and correspondingly you'd have C2 plus. For the minus sign, you have the same thing. So you do get two different sets of C1 and C2. So and the corresponding values of energy, they're there. So if that is the case, would want to recalculate the values of the energies. Notice for P to the plus, it should be this thing. I don't have them in my memory. I've written them down in this sheets of papers, and yeah, and this thing C2. This one's C1 minus. All right. So let's simplify this thing. I'll spoil it for you guys. The energy split that we needed to calculate in part A, I believe. So that thing remains the same. It doesn't change, right? It doesn't change if you consider C1 plus C1 to C1 minus, right? It still remains beta, which is like which was epsilon square for delta square. So let's work it out explicitly so that can put your mind at ease. So here you'd have C1 plus times 1 minus. So is it minus? No, it's not. It's delta plus by 2 pi by C1 plus. So what happens is C1 plus goes away, right? And this thing happens regardless of the sign of C1. That's why we're gonna get the same splitting value for E. And the same thing happens here. I'm not gonna work it out. You can check easily. So now if I have to find the energy split, it's given by this expression. And if we write it down, it's delta. Beta, right? Let me see. That was plus beta. And have plus here, plus here. With beta by delta. Now, are we missing something? So we have a factor 1 by delta in the answer. It should not be there, if I remember correctly. Let me check if I've made a mistake. Right, I have. So here you have delta multiplied factor. Delta here, delta here. Now what will happen is that delta goes away. This delta goes away, goes away, goes away. So you have the same answer. Right, that was the correction. I'll now move to finding the current, probability current at time t is equal to 0. So remember the probability current is defined as this thing. Let me zoom in. Right. What you need to find out is the value at t is equal to 0. PR, if we remember correctly, is given by half this expression where E2 is basically the energy corresponding to the plus value and E1 is the one with the minus value. That being said, let's find this thing, simplify this thing so that we can take the derivative. Let's use the fact that E2 minus E1 is defined as the energy splitting E. So, and also we use the Euler identity. So it would be and the expression for PSMs. All right. The reason I'm spooked is because this thing goes away, right? If we proceed in this manner, the cos et part goes away. What remains is the I sine et part. Now, what it does is it makes the whole expression complex. That should not be the case because we are taking the mod square, right? We're taking the mod square. There has to be something wrong in this calculation. Let me check. Yeah, yeah. Uh, Now I said. So yeah, what's wrong is that when you multiply this thing with this, you get a minus sign. So you have minus here and minus here. This thing goes away. Not the cost part. So you have this, which ultimately gives you 1 minus cosine of et. And yeah, let's skip it this way. Could have simplified it a bit using trigonometric identity, but I bother. So pi is given by this expression, and notice this is always a positive number, right? Cos cos of theta cannot be greater than 1, so that's that. Now let's calculate the value of the probability current. Which is given by this expression at t is equal to 0 at turns to 0. I believe that concludes the answer for question B. We'll now move to question C.